Hi there! In this video, we're going to talk about arithmetic sequences and the difference between the explicit and the recursive formulas. So first, something to note is this word right here looks like the word arithmetic. We pronounce it arithmetic sequences. And what is an arithmetic sequence? It's a pattern. It's a pattern of numbers where you add the same number to get the next number in the pattern. Now note that sometimes the number that you add can be a negative number, so it does look like the number is subtracted, but it's easiest just to think about adding and know that we can either add a positive number or we can add a negative number. Just depends on the pattern that you're dealing with. So I made an example down here to use to kind of help talk about both kinds of formulas that we're going to be talking about, our explicit formula versus our recursive formula, but just as an example to talk about a couple basic things. So the first thing that you're going to need to know is when we're dealing with this sequence, we talk about term numbers. So if I'm looking at a term number is literally like each number. So this is going to be the first number, this is my second number, this is my third number, this is my fourth number in my list of numbers. Those are referred to as term numbers. And then something else that we want to also pay attention to is how much we're adding every time. And that's something that's called the common difference. So this pattern is kind of fairly easy to look at. You can say, all right, well here, to get from 3 to 6, you'll notice that you added 3. And to get from 6 to 9, you'll notice that you added 3. To get from 9 to 12, you'll notice that you added 3. This one was pretty easy to find. This is what's called the common difference. That second F looks a little bit funny. Let's fix it. The common difference. Okay. And so just note that you notice that this number is going to be the same every time how much you're adding to get the next term. So let's talk about the explicit and recursive formulas. So the explicit formula looks like this. And let's talk about what these means. So we've learned about what a term is, and we've learned about the common difference. So this A, we say this A sub n. This sub means subscript, which is the number that's kind of written on the bottom. And this n, if you'll see here, represents my term number, which we already talked about, which is just the number of where it falls in the list. So this one right here, A sub 1, represents my first term, where A sub n would represent my nth term. And we would say nth because we don't know how many terms yet we're looking at in our pattern or in our sequence. We said that n already represents the term number, and this d represents the common difference that we talked about, which is the number that you're adding to each term to get the next number. So up here, we said, oh, it was fairly easy to find the common difference. We noticed that it just jumped up by 3 every time. So sometimes it's not as easy to see, especially when it's a negative number. So to find the common difference here, I wrote that the common difference, you always take the second term. That's what this means, A sub 2 minus A sub 1. You always do the second term minus the first term. So if I did this here, you would see that my second term was 6. I'm looking up here now. My second term is 6 and my first term is 3. So 6 minus 3 is equal to 3. And then I wrote then check. So then check. To get from my first term to my second term, did I add 3? To get from my second to my third, did I add 3? Why, yes, I did. To get from my third to the fourth, did I add 3? Yes, I did. You always want to make sure that the pattern is consistent because sometimes they do try to trick you and give you the first couple that are the right pattern, but then the next ones are not. So always make sure that when they give you a sequence of numbers that it follows the pattern that you think it has. Okay, so if I wanted to write a formula for this pattern that I came up with, 3, 6, 9, 12, in this explicit, with this explicit rule or this explicit formula, I'm going to say that my nth term equals my first term. What's the number that comes first? Let's see, my first term I made blue. So my number that comes first is going to be here, which in this case is 3. Now I haven't found a term number yet. So we're using these equations to find term numbers. And then, so the only things that you really need to fill in are the first term and the common difference, which is going to be here, which we decided was also 3. Now, it happens to be a coincidence that both those, the first term and the common difference, are 3. That is not normally the case. But this is how you would write the formula. So if somebody said, write a rule, this is what you would do. Now, you can use that rule. So let's just say, I wanted to say, all right, can you find for me the 50th term? Well, sure, you could go ahead and you could count, okay, 3, 6, 9, 12, 15, 18, 21, 24. You could keep counting. You could do that. Or you could use this formula. This formula says I take my first term plus I plug in my term number, so notice my term number is 50. I'm going to plug in 50 here because that's what I'm trying to find, my 50th term, minus 1 times 3. So this becomes 3 plus 49 times 3. So I would use a calculator if I needed to multiply 49 times 3. Gives me 147 equals 3 plus 147 and adds together to equal 150. So my 50th term, if I kept going all the way in my pattern up here, would get me to 150. You might say, well, sure, I could just say 3 times 50. Well, you could for this example, okay? But in general, how to use this formula, that's what you would do. We use the explicit formula when they're asking you to find large term numbers, or they want you to write a rule for the sequence that they've given you. Okay, so then we have what's called this recursive formula. So the recursive formula uses something that we call the previous term. So this right here, a sub n minus 1, stands for previous term. So when we write a recursive rule, we need to know 2 things. We need to know what the first term is, which is why I have a sub 1 is equal to whatever number it is. And then my nth term is equal to my whatever difference is plus my previous term. So in this case right here, I can say that my first term, if I look at my example, is equal to 3. I'm going to put a line here so it's kind of like a blocker so I can focus on this recursive side. My nth term is equal to my common difference, which we found was 3. So I'm going to just highlight here, this one was this 3, and this one is the green 3, plus my previous term. That would be the rule that I would write for a recursive formula. So how would I use it? Let's just say I wanted to find the next couple terms. I can use my previous term to do that. So I end right here on term 4. Now, yes, we know that we just add 3 to get to the next number, and we know that the 5th term is going to be 15. How the formula works, though, if I said I wanted to find a sub 5, I take 3 plus my 4th term. And my 4th term, if you look up here, is 12. So what's 3 plus 12? 15. So when would I use this formula? Well, if they wanted me to find multiple terms in a row, I would also use it if they wanted me to find a low term number. Okay, so I have a couple examples for you on top of this one that we just did to talk about the difference between explicit and recursive. So this first one here says, write a rule using the explicit formula and find the 100th term. So my explicit formula says a sub n is equal to a sub 1 plus n minus 1 times d. All right, so I have to find my first term. What color did I use? I used blue for first term. So my first term is literally the number that comes first. So my first term right here is going to go written right here. Now I have to figure out what's my difference. Okay, we said to find the difference. Whoops. I'm going to take my second term minus my first term. Okay, so my second term is -5 minus my first term is -12. Okay, so minus a negative is the same as adding the opposite. So this becomes -5 plus 12. How much is -5 plus 12? 7. Okay, so my common difference, which we had as green, is going to be 7. So if I write my rule, I said that a sub n is equal to -12 plus n minus 1 times 7. And I can leave it like that. Sometimes your teacher or the textbook might want you to multiply this out. So you could multiply this out and you would distribute the 7 and say this was 7n minus 7, and then this would give you -19 plus 7n. You could write it out that way if it asked you to, but you don't have to. So then it wants you to find the 100th term. Okay, so to find the 100th term, I say a sub 100 is equal to my first term, -12. I just like to use this rule right here. I don't like to use the multiplied out one. I think it's just easier if I do it like this. -12 plus 100 minus 1 times 7. Okay. So -12 plus 99 times 7. I'm going to have to move them up here. Gives me -12 plus 99 times 7. Use my calculator. (99 times 7 is 693 minus 12. Gives me 681. So my 100th term is equal to 681. Now, that's a lot nicer than saying, okay, plus 7 here, and then plus 7 here, and then plus 7 here, and then plus 7 here. You can see how tedious that would get to do that 100 times, basically. So that's why this explicit formula is really nice. Okay. Now we want to write a recursive rule for the sequence below and find the next 3 terms. Okay, so my recursive formula says I have to write my first term. That's easy, my first term. Literally the number that comes first, so I just write my first term as 4. Then, to find my nth term, I have to find my common difference plus my previous term. Okay, so to find my common difference, I take my second term minus my first term. So I do -3 minus 4 gives me -7. So my common difference is -7, which is going to go here. You have to have both of these things when you write a recursive rule. All right, so now it asks me to find the next 3 terms. So what term numbers do I have? This is my first, second, third, fourth, fifth. So I need to find terms 6, 7, and 8. So to find my 6th term, I have to do -7 plus a to the 6 minus 1, or -7 plus my 5th term. And my 5th term is -24. -7 plus -24. I can use a calculator if I can't figure that out quickly in my head. Gives me -31. This is my 6th term. My 7th term is equal to -7 plus my 6th term, which I know is -31. I add those together. This gives me negative 38. This is my 7th term. And to find my 8th term, I take negative 7 plus my 7th term, which would be negative 7 plus negative 38. Which is negative 45. So up here, I would say that my next 3 terms are negative 31. I'm going to have to kind of write small. Negative 31, negative 38, and negative 45. I separate them with commas. And if I put them in a list, I always do comma, dot, dot, dot. But because they just asked me for the next 3 terms, that would be my final answer. So this part, my equation, and my next 3 terms. So remember, explicit is this formula right here, where we have, that can help you find literally any term number that you need. You just need to know what term number you're trying to find. This recursive formula is really just to find terms in a row, but it is convenient in certain situations. So now you understand the difference between the two, and if you have any questions, let me know. Good luck.